Okay, this is part 2 of the video. Somehow I hit stop instead of pause. So what we're doing is we need to now clean this up using over operations. What you should see is that you have a negative of negative 12 or an opposite of negative 12. So therefore it will become 12 plus or minus the square root of negative 12 squared. Negative 12 times negative 12 is 144. And then you come over here to negative 4 times 1, which is still negative 4, times 20. So that would be minus 80. And all of that is over 2. And then we just keep going, guys. So now we are at x equals 12 plus or minus the square root of, what's 144 minus 80? 64? Now you can evaluate 64. What's the square root of 64? It's 8 over 2. Guys, just like yesterday when we completed the square, we have this plus or minus thing going on. That means there are two answers. One of them is 12 plus 8 over 2, and the other is 12 minus 8 over 2. 20 over 2, which is 10, yes? And the other one is 12 minus 8, which is 4 over 2, which is 2. And there are your solutions. I think the quadratic formula is very nice. It's quick. It always works. The quadratic formula, guys, is completing the square in a nice, wrapped up present. If we had more time, I would have actually created the quadratic formula using completing the square. That's how you use it. It doesn't matter what A, B, and C are. You plug them into the right places and you evaluate correctly. Hey guys, watch this. Here's our original problem. I still can bring the 20 over to get this, right? A is equal to 1. You know what would be faster to find solutions than the quadratic formula? Factoring. X, what are the factors of 20? Then give me a 12. Two and 10. 2, 10. They have to multiply to get a positive number, but add up to get negative. That means both of them are negative. X minus 2 equals 0. X minus 10 equals 0. That means x equals 2. X equals 10. Is that not what we just found on the last problem? So you can factor this. You can use quadratic formula. You can complete the square. You can graph it. They will give you all the same answer. Now, not every time is something factorable. That's when you use completing the square and you use quadratic formula.